Welcome to the first I Learn, You Learn, We Learn, in which we discuss lasers and LEDs, the differences and the similarities. Are LEDs and lasers the same thing? Well, yes and no. See, in a material sense, they are the same because they have the same equipment, but it's how their photons work, or their light, that really changes how they come out between whether it being a laser or an LED. But let's get into it. To understand LEDs and lasers, first you must understand what a semiconductor is. So semiconductors are found both in lasers and in LEDs. And to understand what a semiconductor is, you first must understand what insulation and conductivity is. So if you look at copper, copper is conductive, meaning electrons flow with little to no resistance, as opposed to glass, which is an insulator, meaning that electrons do not flow freely between it. Only under certain principles, such as heavy heat, would such principles apply. But you're probably asking yourself, viewer, how does this apply to semiconductors? Semiconductors aren't copper and they're not glass. What are they? Well, they're both insulators and conductors. That's where it changes. So semiconductors are both insulators and conductors. And the way they change is based on their environment, whether that be heat, light, or electrical current. Thanks to the power of semiconductors, things such as computers have been able to make things a lot smaller as opposed to how they used to be. You're probably wondering how the semiconductors finally fit into this whole story on how LEDs work. LEDs are just two semiconductors touching. Normally one's a P and one's an N, meaning that one's positive and one's neutral. The way this works is when electricity moves across these two, it'll call electroluminescence. Electroluminescence is when enough voltage runs between the two semiconductors, allowing it to cause a glow, meaning photons will start to radiate from the two semiconductors. LED stands for light emitting diode. But on the other hand, lasers aren't the same. A laser stands for light amplification of a stimulated what? Laser stands for, and I quote, light amplification by stimulated emission of radiation. That's a little different from light emitting diode, wouldn't you agree? And they work a little different. So you probably hear the words laser diode as opposed to LED, light emitting diode. They both are essentially diodes having the two semiconductors within them. The difference is that the light emitting diode just has two semiconductors. And when the voltage runs across the two, you'll have photons being emitting, coming out in the form of light. The difference is that for lasers, there's a third area between the P and the N. The positive and the neutral semiconductor, there's an area called in this intrinsic zone, which is like a mirror. And what it will is the photons will bounce back and forth until eventually they decide to bounce out the top. And this is where you'll have the light emitting from. And so unlike LEDs, which their light comes out in an aura sense because there's no funneling because there's no intrinsic zone, the laser diode has to be focused, so which causes all the photons to go in one direction, meaning that they are very tight in wavelength. So they all have the same wavelength and they move all in the same pattern. What basically happens in this sense is now they need something called a lens. And you'll see lenses all the time on lasers. And these lenses, what they do is they allow to focus the light even further. So the light obviously comes out in a very straight pattern as opposed to the aura of an LED, but it comes out in such a straight line that a lens can change the assortment in the direction. So if you'll see them add different lenses that cause beams to turn or beams to curve or beams to go into different shapes, this is how it occurs with the lens. So we've already talked about lasers, LEDs, and semiconductors. So now it's time to put all this material together and show what is the differences and similarities between lasers and LEDs. And the simple answer is the intrinsic zone is the only difference between a laser and an LED on a material sense. Both have to semiconductors, and these semiconductors are what focus light and create it in the sense of photons. I hope you guys learned something new. I know I did. I hope it wasn't too much vocabulary. I'll put a lot of definitions below. I'll put some facts down. So everything that was discussed will be put down in the comment section so that you can kind of go through all the facts. And if you have any extra facts about lasers or LEDs or semiconductors, please add them below. I'd really love to see all the cool different things that you guys know about lasers and LEDs that I didn't even find out about. And so I'm excited to see you guys in the next I Learn, You Learn, We Learn. Thank you for the first one, and I'll see you guys in the next one.